On a factory floor in the 1960s, automation existed in its rawest form. These massive, stationary arms were built strictly for welding heavy steel and repeating the same endless, heavy lifting motions. Engineers designed these machines to be incredibly fast and highly precise, but they were entirely blind to their environment, completely incapable of sensing or interacting with the outside world. Locked safely inside heavy steel cages, they performed a strict set of tasks, handling the assembly, disassembly, and fueling of heavy industrial parts. In this era, automation served a single purpose: brute physical labor. Lee built machines to function exclusively as tools rather than partners. By the 21st century, the human environment shifted. Modern conveniences like teleshopping, remote work, and digital banking slowly pulled people out of public spaces and kept them inside their homes. This technology gave people far more free time. Yet, as a direct result, modern society became highly isolated. Observing this growing social void, roboticists identified human loneliness as a new frontier for the industry. They began designing friendly systems specifically to assist, support, and join people who had been sidelined by their own technology. This pivot moved engineering beyond the limits of mechanical efficiency. Success now depended on a machine's ability to bridge the gap of human isolation. To turn a machine into a friend, it first had to survive outside of a cage. It needed the ability to safely navigate chaotic, unpredictable human environments without causing a disaster. The solution came through autonomous guided vehicles, or AGVs. By outfitting mobile platforms with external sensors, robots could detect obstacles and map surroundings, like this unit rolling down a hallway in a public hospital. With this basic environmental awareness, mobile surface robots entered public life. They started out handling rudimentary chores, acting as museum tour guides, answering visitor questions, or rolling onto tennis courts to gather stray balls for athletes. Gaining physical mobility and the ability to process external data were the crucial first steps. This allowed automation to leave the industrial sector and roll right into our personal spaces. Sharing a room with a machine is one thing, but bonding with it requires something else entirely. Engineers realized they had to mimic organic behavior to trigger our natural empathy. They started with toys. Early animatronics combined a basic computer chip with small physical motors. By using expressive eyes, simple sensors, and even speaking a fabricated nonsense language, these devices perfectly simulated the harmless unpredictability of a real pet. That concept quickly expanded. Robotic dogs were programmed to recognize external stimuli and interact with each other, simulating the organic playfulness of chasing a ball across a living room. This organic mimicry proved highly effective in therapeutic settings. Robotic kittens, featuring speech recognition, were built to comfort senior citizens, while quietly transmitting environmental data back to remote healthcare workers. Soon, consumer electronics pushed toward the human form. Advanced toys began simulating speech development and striking poses, using the shape of a human body to hack our innate psychological desire to connect. These entertainment robots provided the psychological proof needed to advance the field. They demonstrated that consistent mimicry of life is enough to forge a lasting emotional bond between human and machine. To turn an animatronic novelty into a capable partner, the hardware had to scale up. Engineers set out to perfectly mirror the human form. They designed these new machines with exact human-scale proportions. By building them roughly 120 centimeters tall with a bipedal, human-like frame, the robot could easily reach light switches, open doors, and use everyday gadgets. Achieving this required incredibly complex mechanical stability. Navigating stairs or running at 3 kilometers per hour demanded an entirely new understanding of artificial locomotion. By adopting our physical shape and matching our movements, these creations shed the look of alien industrial machinery. They became relatable, life-sized entities capable of living inside our homes. The third generation of robotics moves beyond physical commands to become context-aware. Through ambient intelligence, a robot networks with dozens of household sensors. It constantly absorbs environmental data, anticipating a user's needs before a single word is spoken. For a machine to serve as a genuine companion, it has to move past merely taking orders. It has to actively understand the context of the environment it shares with you. This leads to the ultimate application of the technology, a personal robot built specifically to listen. Operating as an active counselor, it remains available day or night to process human complaints without judgment or fatigue. Over the years, the physical hardware of the machine will naturally break down. Motors burn out and sensors degrade. But the memory stored inside its digital drive, the shared routines, conversations, and preferences, are completely permanent. You can extract that drive containing a decade of shared experiences and have it implanted into a brand new body. The physical form resets, but the relationship continues uninterrupted. The ultimate triumph of automation lies in the creation of an immortal companion, a machine capable of ending the isolation